Welcome to the DIY Honda Garage channel. DTC code P2096 indicates an issue with the post-catalytic converter fuel trim system being too lean. This diagnostic trouble code arises when the Engine Control Module, ECM, or Powertrain Control Module, PCM, detects that the air-fuel mixture after the catalytic converter isn't at the optimal level, typically indicating excess air or insufficient fuel after combustion. It is essential to understand that the air-fuel mixture ratio must be maintained for effective performance and emissions control. The affected components include the air-fuel AF sensor, which measures the air-fuel ratio to determine how much fuel is needed from the injectors. Sensor 1, located before the catalytic converter, is crucial in this system, while Sensor 2, located after the converter, aids in monitoring its efficiency. Troubleshooting this code requires proper diagnostic procedures, as multiple factors can affect fuel trim, including exhaust system integrity, sensor performance, and electronic control issues. The DTC P2096 indicates that the post-catalyst fuel trim system is too lean, pointing toward a disruption in the air-fuel balance within your Honda Civics exhaust system. The primary components responsible for this functionality include the air-fuel sensor, AF sensor, and the secondary heated oxygen sensor, HO2S. Sensor 1, often referred to as the AF sensor, is positioned upstream of the catalytic converter and directly measures the air-fuel ratio. This sensor's readings enable the ECM to adjust fuel delivery to maintain optimal combustion efficiency. Sensor 2, which is placed downstream, helps monitor the catalytic converter's performance by ensuring the exhaust gases are treated effectively. Any fault in either sensor or an obstruction in the exhaust system can trigger this code, making a thorough examination necessary. When diagnosing DTC P2096, some possible causes outlined include a leaky or clogged exhaust system, which can significantly alter the readings from the AFAC sensor. A leak between the AFAC sensor 1 and secondary HO2S can introduce excess air into the exhaust stream, skewing the measurements and resulting in a lean fuel trim condition. Another potential issue could be a faulty AFAC sensor, possibly leading the ECM to miscalculate the necessary fuel adjustments. Additionally, the secondary HO2S may not be functioning correctly, further complicating fuel trim parameters. Such faults can arise from wear and tear over time, or from physical damage during maintenance. Each of these components plays a crucial role in maintaining an optimal air-fuel mixture, and a failure in any could result in an erroneous report of lean conditions. The symptoms associated with DTC P2096 can significantly affect vehicle operation. Poor engine performance is often the first indication, as the lean mixture can result in rough idling, hesitation during acceleration, or stalling. Additionally, increased emissions can be a critical repercussion since the vehicle may be expelling unburned fuel, which can cause it to fail emissions testing. Furthermore, the check engine light, CEL, typically illuminates to alert the driver of a malfunction within the system. If left unaddressed, these symptoms can worsen and lead to greater engine problems. Thus, careful attention to any of these signs should prompt immediate diagnostic checks to mitigate further complications. The first troubleshooting step for DTC P2096 involves several sequential actions that allow for verification of the fault. Begin by turning the ignition switch to the on-to position, which powers the vehicle's electrical system but does not start the engine. Next, use the Honda Diagnostic System, HDS, tool to clear any existing DTCs, ensuring that you're starting with a clean slate. After clearing, start the engine and hold it at 3,000 RPM without any load applied. The automatic transmission should be in park or neutral for manual transmissions to allow the engine to reach efficient operating temperature. This step helps ensure that the radiator fan is activated, indicating the engine is at an appropriate temperature for testing. The subsequent actions involve test driving the vehicle under specified conditions to properly monitor the OBD, onboard diagnostics status, for DTC P2096. This process is critical to replicate the fault under specific engine conditions to evaluate its persistence. During the second troubleshooting step for DTC P2096, a thorough check of the exhaust system is essential. This includes inspecting for any leaks that may exist between the A-factor sensor, sensor 1, and the secondary HO2S, sensor 2. Any form of leakage can introduce excess air into the exhaust, leading to falsely lean readings reported to the ECM. Additionally, check for potential clogs or blockages in the exhaust system components, which could restrict exhaust flow and impact sensor performance. If any issues are discovered, appropriate repairs or replacement of damaged sections of the exhaust system should be executed. Performing this step diligently establishes a sound foundation for subsequent testing steps, as the exhaust system integrity is crucial for accurate readings from the sensors. For the third troubleshooting step regarding DTC P2096, the focus turns to the air-fuel sensor, AF sensor, itself, specifically sensor 1. Begin by substituting the faulty AF sensor with a known good unit to assess whether the sensor itself was the root of the problem. Ensure to reconnect all electrical connectors to maintain proper sensor functionality. Following this, use the HDS tool to reset the ECM/PCM settings, as this will clear any learning data that may have become stale or irrelevant due to the earlier issue. Complete the ECM/PCM idle learn procedure to recalibrate the system for accurate fuel trim adaptation based on the new sensor's feedback. Lastly, the engine should be tested under the same conditions as prior to monitor OBD status, checking for an indication of whether DTC P2096 persists or resolves with these adjustments. The repair verification step is crucial to ensure that the earlier troubleshooting actions have effectively resolved the issue indicated by DTC P2096. First, turn the ignition switch back to the on position to power up the diagnostic equipment. Again, reset the ECM/PCM with the HDS, allowing it to clear any fault codes and refresh its memory based on the latest modifications made during repairs. The vehicle must then be test-driven under specific predefined conditions, ensuring the coolant temperature exceeds 158 degrees Fahrenheit and the vehicle maintains speeds between 15 to 75 miles per hour to monitor the performance and readjust any parameters as necessary. Subsequently, check the OBD status once more for DTC P2096. If it returns a passed status, the problem has been effectively addressed. If other statuses, such as failed or executing, are observed, further investigation or repetition of prior steps will be essential. To minimize the occurrence of DTC P2096 or related issues in the future, implementing preventive maintenance habits becomes paramount. Regular inspections of the exhaust system can help identify potential leaks or blockages before they escalate into more significant problems, ensuring continuous quality performance. Routine checks of the AF sensors and secondary HO2S should also be part of standard operating procedures, allowing for proactive replacements or repairs that can spare the vehicle from triggering fault codes later on. Furthermore, consistent fuel system maintenance helps maintain proper air-fuel ratios, which is critical for optimal engine performance and emissions control. By staying ahead of potential problems through diligent maintenance practices, vehicle reliability can be significantly enhanced. In conclusion, troubleshooting DTC P2096 requires a systematic approach centered on thoroughly examining possible causes, including sensor functionality and exhaust system integrity. Understanding the roles of the AF sensor and secondary HO2S is key to diagnosing and resolving issues related to the fuel trim system. By following the prescribed troubleshooting steps and conducting comprehensive repairs, one can effectively eradicate the fault and enhance the vehicle's performance. Additionally, instituting regular maintenance practices can help prevent such issues from recurring, safeguarding the engine's health and ensuring compliance with emissions requirements. Dedicating time to practice preventative measures will undoubtedly contribute to a well-functioning Honda Civic, further extending its longevity and enhancing driver satisfaction. Please like and subscribe to the channel. See you next time.